Hello friends, welcome to the Laptex. My name is Nasser, and today we have this Lenovo motherboard, and which part number is LA-K052P. I don't know what is called, which model is that, but Lenovo, this is the Lenovo as it is written. So I have received this motherboard like this. This two IC, the PD controller and the translator IC was short. Only PD controller were missing, and I have found that this particular this IC is uh, short. This is the translator IC. So there are the various types of communication in the C type, and one of them, this is also used in general. There are the lots of like if there is a no translator IC, without translator IC IO would communicate. Here is the SM bus communication, here is the SPI BIOS. So in this model, as you know very well, TPS ICs and RT ICs are coming for the PD controller. This that is the programmed, but here I have used this PD controller, the new PD controller I have used, but I need not to program. Why? Because there is a no SPI program inside. Instead of that, it is outside. Okay, this is the IC which we need to program if it is required. So I have fixed both thing. This the new IC I have used here. Okay, I have brought the two ICs which I have replaced here, and the scenario was that without IC I cannot power. So I fixed it first of all, this one, and this PD controller TPS 6594 AD. So this is the PD controller I have used. Now the scenario is that when as soon as I will plug to the motherboard, you will notice something. It is turning on and off, going up and down. So what could be the reason behind it? So as you start checking voltages, so you will find something very strange that may be very much useful for you, this video. So I'm going to check the voltage here. Okay, so you pay attention on the multimeter. So 19 volt is present here, and 2.8 volt on the other one. So here is the one more thing I have removed. So this is UT3. UT3 was written in the diagram that it is 3 volt, unable for 3 volt. So at last I will jumper it if it is required. Okay, so right now I don't know where it is going, and I have found that this voltage was missing and I have removed it. Maybe that IC could be alright. So now the scenario is that it is turning on and off, and this is the load which is taking. Uh, One question is that voltage is going out to the MOSFET or not. Now it will be distributed from here. So this side we have got 18 volt. So on the gate the high drive is working very well. It means my PD controller is 100% alright. My translator IC is 100% alright. The only thing is that maybe problem in the charging IC or somewhere else. So for your example, 3.3 and 5 volt is required. 3.3 and 5 volt is required when voltage. So you can also repair like this. You need not a diagram like that. See here, you know this type of IC is nowadays SYIC is used very commonly in the motherboard. So now you go and check the voltage 2, 3, 4, 5. Win is here. So is there win in your motherboard? No. And you just turn off and you turn again. There is a no at all. We are not getting any voltage, but however my motherboard is turning on and off, and it is staying load 0.06 milliampere. So maybe my charging IC is not working. So let's come to the charging IC. So in the charging IC, the few thing you need to understand only, if you really don't know how the C type IC works. So for you guys, This is the offer for in the month of August. It will start 15 August. 6.0 Laptex 6.0 course is going to be launched, where I am making only practical videos. Like I have repaired one motherboard, how to repair the digitizer IC, how can you bypass digitizer IC in the Asus VivoBook 13 generation motherboard. So there are the lots of things, because the display is not available on the motherboard. All types of no display case study I am making. Along with that, I will give you my note, that where I have written many things. I have made a diagram also with the hand, and I have described so many things, like how many uh, things you need to check, like when SVID will be generated for the VCC-IN auxiliary voltage. What is the role of that, and is it will you get it on after S5 or before S5? How many things are required for the SVID, and how many LDO will come out from the new generation processor? So many things I have described there. So if you are interested, you can call on the given number. Dildar sir number is given because I am very much busy. I cannot, sorry for that guys, I cannot pick up your call, and I may not respond you even on the WhatsApp. So kindly call to Mr. Dildar. Number is on your screen. Okay. So BIOS, all types of error, and we are highly focused on the no display and all types of PCH signal. Okay. So for that you can avail our course, and now here is the few thing I let me introduce you, that this one, that where is the diagram? Let me open the diagram first. So this is my diagram. So let me show you. Here is the my charging IC. Here is the my charging IC, and my charging IC requires V bus voltage on the pin number 1. So let me check it on the pin number 1. So it is available 18 volt. Also I have to check the I have to check ACN, ACP. Both thing must be okay. So it is the AC, the 2 number pin ACN, and then ACP. So it is also all right. Also you have to check the impedance between both ACP and ACN. Now, if all the things are okay, since there is a no AC detect, no AC okay. Why? Because all things is taken care by charging IC or by your PD controller IC. So now you have to check the region. LDO is generated or not. 28 number pin is the region. So here is 288828. So 6 volt is available. It means my charging IC is working very well. It must switch on the drive to the my MOSFET, so that this MOSFET will turn on, and this MOSFET will allow the voltage to go in the motherboard. So what is the reason behind it? It is not allowing this voltage. This voltage is not going to the drain of this MOSFET. So if you come to the motherboard, so also the guy, he has worked here. Maybe he has tried to remove someone. This is a very common case I am telling you. You must check this one. Usually it is getting short. Okay. So there were so many problems which has been eliminated from the motherboard, and now the points come, that this IC. So the IC number is 36354. So let me bring you to the diagram of the uh, of that MOSFET which is on the motherboard. This is, and this is the MOSFET which I have in my scrap motherboard. So can you tell me that can I use this MOSFET instead of this one? Because this is the motherboard. Here is the little bit more I can show you. Here is the MOSFET number. Okay, and this one is this. So tell me, my VDS is 30 volt, so both has the 30 volt. ID continuous drain current is for Q1. There are the dual MOSFET. Since it is a dual MOSFET, so Q1 is the upper one is the Q1, gate 1 area is the Q1 area, so it has uh, 49 ampere. So here I have 50 ampere, and my Q2 which I am going to use here 60 ampere. So one thing remember, at the point of switching you just don't have to care about the VDS and ID. This thing must be taken care while you are using on the first MOSFET and second MOSFET. But if you are at the point of switching where the voltage will be generated, like here NVDC voltage will be generated with the help of charging IC. So at this point of time, you must be care about the RDS on. Resistor between MOSFET source to drain, what amount of resistor would be there at the time of switching, you must be uh, equivalent. So here it is 5.2 milliampere. My Q, where is the Q1? Q1 is the 5.2. It is around similar 5.3. Q2 uh, 3.9, and it is merely 2.6. So maybe when you are not getting 16 volt or 15 volt at the point of NVDC area, output of the charging IC, so you must look back if you have replaced N channel MOSFET. So you always have to match these area only. Okay. So since I don't have any option, so I will try to use it. But remember one thing, the charging problem could be a reason for this. Maybe instead of higher voltage, like 16 voltage is required as it is written on the diagram. Let me show you as it is written on the diagram. So you may get here around 18 volt, or also you may get here around 13 volt. So if this voltage is less than the battery voltage, so it will not charge the battery. So that is why your maybe you can get this type of issue, that after replacing MOSFET your motherboard got okay, and but your laptop is not charging your battery. So all due to this RDS on. So now I am using it because I don't have any option. So let me change it. Three six three five four dual N channel MOSFET. Shorting must be removed. After removing it, if it is not, then you have to keep on continue searching. It is still here, so it means it is not short, somewhere else shorting is okay. So we have to keep on finding. You have to make sure one more thing. Maybe I'm making mistake. Why? Because this is something that there might be common point. Let me show you. Is it really a problem or not? What is the common thing? The drain and source is common. So what is that? Let me show you. Here is the point. Come here. Here is the point, and let me bring it to here. See, what is the thing which is going to be common? Source 1, drain 2. The first MOSFET source 1, and the second MOSFET drain. So it means there is a no connection between there is no connection between source and uh, which I am checking here. 1 2 3 4 5 6 7, 7 number pin. So this is the pin number 1, pin number 1 2 7. Source 2. My source 2 has no connection with uh, drain. So it means there is a shorting, somewhere shorting, and due to that the shorting area is getting affected and my voltage is not generated. So let me remove the shorting. So maybe uh, the area which is where to where short, let me show you. the area where it is short is in between uh, this coil and not it this is not the coil, this is the area 6 volt after this MOSFET there is a no shorting on the PLB1. So this is the coil, let me show you. PLB1 is my mm, the MOSFET from where I have removed it. Okay, so this is the PLB1. So from the ground, let me check it. So it has no shorting at all. So it means the problem is after PQB2. After PQB2, my drain is pin number 2. Always remember, my drain is on the pin number 2. So which the MOSFET which I have removed, so this should not be ground. So if it is a ground, it means there is something on the motherboard which is short. So I have to keep it aside. Why? Because I have removed it. I thought most of the time this is the common problem, the MOSFET is short. So I am keeping it here in order to check, need I to replace it or not. No shorting, no shorting at all. So it is good, it is very good that my MOSFET is safe. So I will put it back later on. I am going to find shorting. So the easiest method is very common, that you have to put a jumper wire on this area. So you just put a jumper wire on this area and inject some voltage on this point. Okay, so here let me one and two, then 3 4 5 6. Okay, total number pin. Good. Now I have to inject voltage in the motherboard. So let me bring you to this one. Okay, and remove voltage, reduce the voltage here to 0, and let's inject here. Now gradually increase the voltage, 2 volt. Now you see the load little bit more. So before doing this, remove let me remove heatsink, because I don't know that the area that is on the core, even the voltage will go there also. Now I think 10th or 11th generation. So I have to touch, I am really very much scared. Reduce, let me touch it. Everything is all right this side. Let me keep on searching, because I am very much scared. Today I have also already burned. So this regulator is heating too much. This regulator, I don't know what is this, but this regulator is heating up too much. So let me confirm it with the help of only removing jumper wire. So here the guy, oh, the guy, he has also checked So do one thing, don't remove anything, you just clean up this jumper point, clean up like this, and find out this area is short or not. This side shorting is removed, inside there is a shorting, it means this is the faulty IC. Now remove it. I think this is a 5 volt regulator, JW. Okay, I have removed it. Now shorting must be vanished. Yes, of course, it is gone. So shorting is removed. Now let me remove the jumper wire and solder back the same MOSFET. It is very good because I had suspicion on my MOSFET from scrap motherboard. Come on. Yes. There is a too much solder here. It could connect from inside. That is why clean up. All right. Nothing to do on it. It is very good. And here I have placed the jumper back, and I have to bring a regulator which name is 5 volt. That is a very difficult task for me. Dell scrap motherboard, and hopefully I will get it on it. First of all, let me show you what is that which I have removed. Okay, so the IC number was in my motherboard PU502. PU502. So this is 16 volt will come here and it will release 5 volt. My guess was absolutely right. So here is the 3.3 volt and 5 volt regulator. Something is okay. See the condition. Since it is a scrap motherboard, so one regulator is here, one is missing. I don't know which one was the 5 volt, but let me open up the diagram of my scrap motherboard. So let me open it. Sorry guys for that my video is going long. Hopefully you don't mind. So this is LA-F401P, and I have fortunately this board view also, and where is the PDF diagram PU100, which is available 3 volt. Oh, 5 volt is missing, I think so. PU102 5 volt, this is missing. I need another motherboard. Do I have in this motherboard? This is different motherboard, and I think PU 100, and here is the, but this is the different motherboard. I have the different motherboard. The part number is LA-G891P. The same thing is written here, uh, but one thing, let me show you. Let me show you here. If you reach to the uh, 5 volt regulator, if you reach to the 5 volt regulator, the 15 number pin is NC, not connected. If you get 15 number pin, if you get capacitor, it means it is your 5 volt regulator. Now you come and check how you can do, how you can repair motherboard without schematic. If you get any capacitor on the 15 number pin, 100% this is the 5 volt regulator. 5, 10, 15. 15 number has capacitor, so it means it is a 5 volt regulator. Here, see here, 5, 10, 15. 15 has no capacitor at all, so it means this is a 3 volt regulator. This is the way you can recognize your IC. So now let me remove it from motherboard. What was the name, WJ and JC, and what was written there on the IC? You don't care about that. SYIC will work here, and SY number is SY828, sorry, SY8, I'll show you. Okay, it is very common IC. Now removed. Pin number 1. Why? Because 2 number is win. 2, 3, 4, 5 all are the win. And I have to use this capacitor, whatever it is, I have to use it. Why guy work like this? I don't know. Oh, sorry guys. Uh, Lots of air I am using here because I want to work this very quickly. That is why my uh, air is on the 100. Quick 861 DW I'm using, 500 temperature, and air is on 100. Few capacitor is required. I don't know what is that pin number. You just count the pin number. What is the pin number? 5, 6, 7 number pin. What is the 7 number pin? Have a look here. Your 7 number pin is ground, but win requires some. Okay, against 5 to 7, the capacitor is required. So always remember, you cannot miss it. So I am going to take the big one. Only single capacitor I am going to use here. Okay. Alright guys, if you wish you can use few more, but you have to use it. because the current will need to be discharged when you plug out the current need to be discharged, and the capacitor helps to discharge the current. Now I hope that everything will work fine. Finally I am going to check that shorting is removed or not. So alright, shorting is gone, shorting is gone. Okay, and one side is ground, this side has power, so the value is 500. It is little bit less, maybe due to heat up. Now I am uh, injecting power. Now let me increase the voltage 11, 19, 20, and this is the DC jack, plus and minus. Okay, now I have injected the power, and I have to only check voltage first of all, that my voltage is available or not. So anywhere you can check. Here you have replaced the IC, so you check here, so it is on the beep. Now my 12 volt is ready. It was written 16 volt, but 12 volt is also enough, and 5 volt, yes, ready. And what about my 3 volt? So 3 volt maybe here, 3 volt maybe here, 5 volt is I think where is the 5 volt? 2 5 volt. Okay, all right. Now turn on. It is turned on, but load is still low, so I have to work too much hard. And we need to know that how many things are generated, like RAM voltage. No, I think let me turn on once again. I have turned on 0, 5. I need to check it. Yes, 3. This one is 3. This one is 3 volt. And what is this? 5 volt. How 2 5 volt could be there? This is the 5 volt. This is also 5 volt. I don't believe it. So here is the 5 volt. I am checking you this one, which IC I have changed 5 volt, and here we are also getting the 5 volt. Do you believe it that 2 5 volt could be there? Maybe guy has done something wrong. So I have to keep on working like this way, because in my country the guys who messed up motherboard, if they cannot repair, they should send it to us, but they don't send it. They will remove it, they will research it, they will make so much R&D on the motherboard, and then I receive these types of motherboard. The condition you have seen it. So inshallah, you if there is some possibility, if the CPU is good, I am damn sure that I will repair this motherboard. If there is something interesting, so I will show you in next video. So hope that you have enjoyed this video, and if you really like it, subscribe our channel, and hit press the hit button, like button, and kindly share the video, because other also can be benefited, and keep on loving us like this. If you are interested in our course, then you can contact on the given number, and see you guys, see you in the next video. Thank you guys, thank you for watching this video.